For over half a century, the commercial aviation industry has been dominated by a few powerful giants, each making cautious steps forward rather than bold leaps into the future. The skies have long been ruled by Boeing, Airbus, and a handful of others who've improved efficiency and comfort, but never truly rewritten the rulebook. However, that might be about to change in the most dramatic way possible. A wave of speculation is spreading like wildfire across the internet and in engineering circles, all pointing towards something that could redefine the very nature of flight: the rumored $79,859 Tesla super-electric plane. At first glance, the idea seems almost unbelievable. An advanced aircraft that could cost less than a high-end car, run purely on electricity, and even be flown without a pilot's license. But then again, this is Tesla we're talking about, a company that has repeatedly done the impossible. From turning electric cars into global bestsellers to building rockets that return to Earth and land themselves, Elon Musk's ventures have constantly pushed against the boundaries of what people thought could be done. And now, Tesla appears ready to do the same for the skies. So, what makes this aircraft so extraordinary that some analysts are already predicting Boeing and even private jet manufacturers could be facing an existential threat? To understand that, we need to look at the core of Tesla's innovation, its ability to combine battery technology, AI automation, and cost-efficient design into one seamless system. The promise of a $79,859 super-electric plane isn't just about affordability, it's about accessibility. Imagine owning a sleek, futuristic aircraft that doesn't require years of training, complicated controls, or even a pilot's license. The vision behind this new Tesla plane is a flying machine that anyone can learn to operate safely through AI assistance and full autonomous systems. Musk has long teased the idea that advanced autonomy could one day extend beyond cars and trucks into aerial vehicles, and it seems that day is coming faster than anyone expected. Here's the part that truly changes everything. Thanks to its neural-linked AI flight control system, Tesla's plane would act more like a co-pilot than a traditional aircraft. The onboard system handles navigation, turbulence, correction, vertical takeoff and landing, and obstacle avoidance entirely on its own. All the passenger has to do is set the destination through Tesla's navigation interface, similar to the one used in its cars, and the plane does the rest. This means anyone could theoretically fly it safely without the need for a traditional pilot's license. You might be wondering, where can someone actually fly a machine like this? According to early rumors and discussions among aerospace engineers, the Tesla super-electric plane is being designed for both private and short-range commercial operations. Its vertical takeoff and landing system allows it to operate from small airstrips, parking decks, or dedicated vertiports that could soon be built in urban centers. In other words, this isn't just a plane, it's an entirely new form of local air travel. Picture this. You leave your home, drive to a nearby Tesla charging hub, and instead of plugging in a car, you board your electric plane. Within minutes, you're airborne, no long security lines, no crowded terminals, and no delays. The flight path is automatically optimized by Tesla's AI to avoid weather systems and ensure maximum efficiency. You land directly at a vertiport near your destination, and the entire process takes less time than a single airport check-in. This is what Tesla means when they say it's a plane for the masses. Super-electric plane aims to make private flight as simple and affordable as driving a Model 3 at under $80,000. It's cheaper than many luxury sedans, and with Tesla's battery expertise, operating costs could be a fraction of those of conventional aircraft. No jet fuel, no oil changes, just pure electric propulsion with almost zero maintenance. But of course, the big question every engineer asks is this: how can Tesla overcome the one challenge that has grounded so many other electric aircraft, the sheer weight of batteries? Traditional lithium-ion batteries are dense, but not nearly energy-dense enough to sustain long flights without adding enormous weight. However, Tesla's latest research into structural battery packs and aluminum-ion technology could be the breakthrough the aviation world has been waiting for. Instead of carrying batteries as a separate payload, Tesla integrates them directly into the body structure of the aircraft, turning the fuselage and wings into energy-storing components. This design not only saves weight, but dramatically improves energy efficiency and rigidity. Even more impressive is the possibility that this plane could feature the same fast-charging architecture as Tesla's newest vehicles, allowing full recharge in around 12 minutes. Imagine landing, plugging in, grabbing a coffee, and being ready for another 400-mile flight before you finish your drink. If true, that would shatter every existing barrier to electric flight practicality. And speaking of flight range, just how far can this thing really go on a single charge? Estimates suggest a range of roughly 350 to 400 miles, depending on passenger load and weather conditions. While that might not sound like much compared to a commercial jetliner, it's absolutely game-changing for short-haul travel. Most regional flights in the US, Europe, and Asia fall well within that range. For business travelers, commuters, and even emergency responders, this kind of distance would be more than enough to cover daily operations, of course. Whenever you're dealing with electric propulsion at 30,000 feet, one of the first safety questions that arises is, what happens if lightning strikes? Traditional aircraft rely on conductive aluminum skins to safely channel lightning away from critical components. Tesla's plane, on the other hand, would likely use a layered composite material infused with graphene, a conductor stronger than steel yet far lighter. This allows the plane to handle electrical discharge without damaging internal systems. In fact, Tesla's design philosophy emphasizes redundancy. Multiple independent circuits ensure that even if one system fails due to a surge or lightning hit, the others continue operating seamlessly. This same safety-first approach extends to its aerodynamics. Traditional air brakes on commercial planes are large, mechanical flaps that increase drag when slowing down. Tesla's electric aircraft would use smart morphing wings, surfaces that subtly change shape through electronic actuators, allowing smoother braking and better control at any speed. The result is a more stable, quieter flight and a shorter landing distance. Now, here's something almost no one talks about: electromagnetic pulse EMP resistance. In an increasingly digital world, the idea of an EMP or a sudden electrical short isn't science fiction. It's a genuine concern. Tesla's engineers are reportedly building and hardening measures to shield critical electronics and control chips from EMP events. If successful, it would make this aircraft one of the most resilient air vehicles ever created, able to maintain flight control, even during severe electrical disturbances. But what truly separates Tesla's concept from anything Boeing or Airbus has attempted is its reimagined propulsion system. Instead of relying on conventional propellers or jet turbines, the super-electric plane may use distributed thrust, several smaller electric fans embedded within the wings. This approach not only enhances lift and reduces drag, but also improves redundancy. If one motor fails, the others automatically compensate. During takeoff, these electric fans deliver instant torque, allowing near-vertical ascent, something no traditional airplane can do. Tesla's engineers reportedly call it smart thrust. It's a system that dynamically shifts power between motors to optimize performance and stability. The takeoff feels more like an elevator rising smoothly than a roaring jet accelerating down a runway with zero tailpipe emissions, minimal noise, and operational costs that could be 70 to 80% lower than current short-range aircraft. This Tesla creation could completely redefine what we think of as air travel. Cities could see reduced airport congestion, and smaller communities could connect via regional vertiports, creating a decentralized network of electric flight corridors. Now, skeptics will argue that Tesla has never built a plane before. True, but remember, they hadn't built rockets before SpaceX either. Musk's entire career is about crossing boundaries and converging industries. His companies are uniquely positioned for this challenge. Tesla already dominates in high-end city battery technology and autonomous systems. SpaceX has unmatched expertise in lightweight aerospace materials and atmospheric flight control. Combine those two forces, and you have everything needed to Build the world's first mass-market electric aircraft. What makes this project even more fascinating is how it aligns with Musk's long-term mission to decarbonize transportation across every mode, from ground to air to space. He's often said that the key to sustainable aviation lies in ultra-energy dense batteries. And with recent breakthroughs in 4,680 cells, sodium-ion alternatives, and aluminum-air chemistry, the timing finally makes sense. There's also a strong economic angle. At $79,859, this isn't just a high-tech toy for billionaires. It's strategically priced to undercut the private aircraft market, while appealing to commercial operators and government agencies. Imagine air taxis, rescue drones, or even delivery services using Tesla's plane as a low-cost, zero-emission solution. The cost savings extend beyond just fuel. Electric moto.